Hello everyone. Today we're going to be discussing the end behavior of a polynomial function. I'll give some tips and tricks for remembering which of these is which other than just memorizing. And we'll also go over these examples and discuss what the end behavior is of all of these five polynomial functions. So let's dive in. Okay. So first of all, what do we mean by the end behavior? We mean what eventually happens. So as x is approaching negative infinity, what is f of x or y approaching, right? Is it as x is getting lower and lower, is y also getting lower and lower, or is it getting higher and higher? What is happening to it is essentially what this means. And the great thing about the end behaviors for polynomial functions is that they all pretty much have the same pattern to them, right? As long as we can figure out what the degree is and the leading coefficient is, all polynomials with the same degree and same leading coefficient are going to have the same end behavior. And so therefore, there's only four categories that end behavior of a polynomial can even fit into. Because it's either odd degreed and has a positive leading coefficient, it's odd degreed and has a negative leading coefficient, or it's even degreed, has positive leading coefficient, or it's even degreed and has a negative leading coefficient. So that's the good news about these. So let's look at this first category here on our top left. It says when the degree is odd and the leading coefficient is positive, that as x approaches negative infinity, so as we're getting further and further left, f of x is approaching negative infinity, meaning we're getting further and further down, right? Notice how both of these, as we get further and further left, we also get further and further down as well. And one way to think of this is that all polynomial functions that are odd and positive, like a linear that is, that has a positive leading coefficient, has the same end behavior. So oftentimes we compare this to a line because that's how, that's what this pattern follows. And same thing with as x approaches infinity. As x approaches infinity, or right, as x gets larger and larger and larger, as we go further and further right, we're also going further and further up, right? Or same with here, we're going further and further right and further up. Now, sure, we're doing it at different rates, but the end behavior does not refer to the rate at which we're going up or left or right or anything like that. It just refers to whether we are going up, down, left, or right. Okay, in this next example here, we have, what if we have an odd degree and a negative leading coefficient? Well, in this case, all of the polynomials, go the same way that a line would, a line that slopes downwards. As x approaches negative infinity, or in other words, as the line goes further and further left, f of x approaches infinity, meaning it goes further and further up, right? So here, as we can see in both these examples, as we get further left, we also go further up. And as x approaches infinity, right, so as the line or the other polynomial function goes further and further right, f of x, right, the y value, it approaches negative infinity, going further and further down, right? And we can see this illustrated here and here as well, where these functions are going, as they go further and further right, they also go further and further down. Okay. What about these two right here? What if we have even degrees? So for even degrees, I always like to compare them to quadratics, right? If we have an even degree and a positive leading coefficient, such as y equals x squared, that means that as whether x approaches infinity or negative infinity, f of x is always approaching infinity. And my apologies, I see this extra negative sign here. This should not be here. Let's take that off. There we go, right? Because here, either way, whether we're going far, far left or far, far right, we're going up in both directions, right? This parabola opens up no matter what, right? And same with this function here. This function here, as we go further and further left or further and further right, we also go further and further up, right? So we can compare any even degreed polynomial function that has a positive leading coefficient to a quadratic that has a positive leading coefficient, because they all have the same end behavior. And something similar can be said about this last example, where we have an even degree and a negative leading coefficient, that whether x approaches infinity or negative infinity, f of x is approaching negative infinity. Or in other words, whether we go far, far left or far, far right, we go further and further down, right? And so we can compare this to the end behavior of a quadratic that is opening down. All right, well, now let's get into the examples because, I'm sure that's probably why most people are actually here, is to see those examples, not to necessarily get this explanation. So let's go through the examples. So all we need to do is we need to list what is the leading coefficient sign and the degree, and then choose which category it falls into and just copy the end behavior from that category. And that's all there is to it, which is great. Okay, so first things first, the degree of the leading coefficient. Well, here it appears the leading coefficient is 3, so that's a positive number. So the sign of the leading coefficient is positive. And then what is the degree? The degree just refers to what is the highest power, right? So the highest power in this case is 5. And 5 is an odd number, so we would say it's odd degreed. So now I'm going to go back to over here. We want something that is odd degreed, and the leading coefficient is positive. So that fits into this first category right here. So therefore, as x approaches negative infinity, so does f of x. And as x approaches infinity, so does f of x. So I'm just going to write that down, that as x approaches infinity, or as in other words, as we go further and further right, we also go further and further up. And as x approaches negative infinity, right, or we're going further and further left, we're also going further and further down, right? Because this has the same end behavior that a line with a positive leading coefficient would have. Even though it's a degree 5 polynomial, it still has the same, it's still odd degreed, right? Just as a linear function would be odd degreed. Okay, let's move on to the second one here. First thing is the sign of the leading coefficient. Well, here the leading coefficient is -1, right? And so the sign here is this negative sign. So the leading coefficient is negative. The degree is degree 6, which is an even degree, right? Because 6 is the highest power, right? The very first thing there is x to the power of 6, and none of the other exponents are that high. So therefore, we need to compare this to a quadratic that opens down, right? Because a quadratic is also an even degree polynomial function as well. Okay, so a quadratic that opens down, as we go further and further left, we also go further and further down. So as x approaches negative infinity, so does f of x. And as x approaches positive infinity, f of x approaches negative infinity, right? Because it opens down, if you can picture it, right? It does open down in both directions, right? A quadratic that opens down will go downward in both directions, and this even degreed polynomial function with a negative leading coefficient will exhibit that same end behavior. Okay, let's try this third one. So here we have the leading coefficient is 0.78. So that is a positive leading coefficient. And the degree is 3, as that's our highest power. And so that's odd. And so this is going to follow the same end behavior as a linear, right, which is also odd degreed, that has a positive leading coefficient. So same end behavior as a linear that slopes up, meaning that as x approaches infinity, right? As we go further and further right, we also go further and further up. F of x approaches infinity. And as x approaches negative infinity, or we go further and further left, we are going further and further down. So f of x is approaching negative infinity as well. All right, let's try D. So for D, our leading coefficient is -2. So therefore, the sign of our leading coefficient is negative. The degree is 7. Degree is 7, and that is odd. And so therefore, this is going to have the same end behavior as a line, right? Because a line also is in the odd category that slopes downwards, right? And so as x approaches infinity and goes further and further right, f of x approaches negative infinity because the function goes further and further down. And then as x approaches negative infinity, or goes further and further left, the function f of x goes further and further up. It approaches positive infinity now. All right, and let's do one last example here. Here we have our leading coefficient sign is positive because 1.4 is a positive number, and our degree is 8, which is an even number. And so therefore, the end behavior is going to be the same as the end behavior of a quadratic that opens up. So therefore, as x approaches infinity or negative infinity, either way, it's going up in both directions. It's opening up. And so therefore, f of x is approaching positive infinity for both, right? As we go further left and further right, we're going further and further up both directions. All right, well, as always, feel free to leave a comment below if you have any questions, and we hope to see you for the next one.